Assalamu alaikum students, this is Ms. Beena. I'm here to give you the second lecture of chapter Shifting the Equilibrium. This is the part of your March breakup. Let's have a short revision of the previous lecture in which we discussed Le Chatelier's principle in detail that states that when a reversible reaction is in equilibrium and you make a change, it will do what it can to oppose that change. We discussed it in detail by the example of nitrogen reacting with hydrogen to form ammonia, that whenever this reaction reaches equilibrium and we induce a change, then the equilibrium mixture will do something to oppose that change and restore its equilibrium condition. We also discussed that increasing the temperature is inversely proportional to the yield of ammonia because that reaction is exothermic, so it is not good for the yield. Now let's move towards the next change, which is increasing the pressure. What happens when we increase the pressure of the reaction? Pressure is basically caused by collisions between gas molecules and the walls of the container. So definitely in this reaction, the equilibrium is reached and a suitable pressure is already maintained in the system. The fewer the molecules present, the lower the pressure. But if you apply more pressure, the equilibrium mixture will act to oppose that change, as explained by Le Chatelier's principle. If we increase the pressure, equilibrium will be broken and more nitrogen and hydrogen will react to reduce their amounts, because definitely if we are increasing the pressure, so equilibrium will try to reduce the pressure by reducing the amounts of the nitrogen and hydrogen molecules. So more ammonia will form in order to reduce the number of molecules. The result is that the level of ammonia increases. So equilibrium shifts to the right side of the reaction. So definitely we are on the right track. If we increase the pressure, it will improve the yield of ammonia. So it is good for the yield. Now the next change is removing the ammonia. The equilibrium mixture is a balance between the levels of nitrogen, hydrogen, and ammonia present. Suppose you cool the mixture, ammonia condenses first, so you can run it off as a liquid. So what we are doing, we are removing some of the amounts of ammonia which is produced in the reaction. So if we remove the amounts of ammonia, so what is its effect on the reaction? Will it become faster or slower? So to remove ammonia, we have to liquefy it because it is a gas. So we will cool down the mixture, the ammonia condenses and it is removed easily. Then again, we will warm the remaining mixture. Since the amount of ammonia is reduced in the mixture, then equilibrium is again disturbed and more nitrogen and hydrogen will react to restore the equilibrium. So the level of ammonia again increases. So this is also an option to increase the yield of ammonia. Now the next change, or you can say the next factor, is adding a catalyst. What is the effect if we add a catalyst in the reaction? Iron acts as a catalyst for this reaction between nitrogen and hydrogen. But note down that it speeds up the forward and backward reactions equally. Although the reaction reaches equilibrium faster, the equilibrium position doesn't change. It means that if we are adding the catalyst in the reaction, it will not increase the yield of ammonia, but what it will do is it will reach equilibrium faster. So still the catalyst is worth using because it saves time to reach equilibrium and therefore money, because we are providing suitable temperature, suitable pressure to the reaction to reach the equilibrium and to perform this reaction. So we are definitely using our money and we are performing this reaction, which is commercially very important. So if we add catalyst, so our equilibrium will be reaching faster and the amounts of ammonia will be produced earlier. So it is also not a bad option. Choosing the optimum conditions. Now let's summarize all the factors and all the changes which can increase the yield of ammonia. So all the conditions which are good for the yield are called optimum conditions. To make production economical, you have to balance all the above factors. So, to improve the yield, what we have to provide? High pressure, low or moderate temperature, catalyst to reach equilibrium faster, and remove ammonia from the reaction during the equilibrium condition. Now, the question which I have formulated is slightly different because I have chosen another reversible reaction for you to be solved. This reaction is hydrogen reacts with iodine to form hydrogen iodide. It is a chemical reaction which is exothermic and reversible in the same way as we have discussed the reaction between nitrogen and hydrogen. So it is the same kind of reaction. You are supposed to write the chemical equation for the reaction first, and B is what happens to the yield of hydrogen iodide if you increase temperature, if you increase pressure. So there are three parts of in this question you're supposed to answer. I hope you are understood with the chapter. Here the chapter is completed. Please complete all the questions by yourself, whatever